File 100, Chapter 34, Animal Nutrition and Digestive System. Alright, so the chapter starts off by beginning to define a few different things for you and talk about different digestive systems. Again, this is human biology, so we're really going to focus on the human aspect. I did put a little bit of the other information in this lecture so that you can see it if you're interested in that, but I'll probably be skimming over it for the most part. But starting off with herbivores, omnivores, and carnivores. So herbivores are the animals whose primary food source is plant-based. Carnivores, we probably know even better, are animals that eat other animals. And we have obligate or facultative carnivores in the animal kingdom. And then we have omnivores, which is what humans are considered for the most part, is that we eat, or if you're an omnivore, you eat both plant and animal-derived food and do well eating either one. Obviously, there's also vegetarians and vegans as well. You could probably consider them more on the herbivorous side, but as humans, generally, we're kind of referred to as omnivores. So getting into digestive tracts, what those look like, we have incomplete versus complete digestive tracts. And incomplete means there's a single opening, which is called a gastrovascular cavity. Food is entering through the mouth and exiting through the mouth as waste. And there's no specialized parts or anything. So this is an example of a planarian. This does not apply to humans. Again, just kind of briefly going over this. And then we have a complete digestive tract, two openings, or referred to as an alimentary canal. This humans do have. Food enters through the mouth and waste exits through the anus. So going over some vertebrate digestive systems, we're going to focus on monogastric digestive systems because that is what humans have. Other herbivores like the rabbits also have it, but rabbits actually go through and digest their food twice. But monogastric meaning one stomach basically, or one stomach, one pass through this gastric digestive system. Birds and ruminants are a little bit different. I'll let you go over that if you're interested in it. It's here or in your book. And as far as how we adapt to our diet, dentition offers a good part of that basically. So if you're an omnivore, you're going to have different teeth here that aren't necessarily used for like ripping things apart. And it could, but you could have some like sharper ones, like our incisors up here that you have for clipping, and then you have some premolars and molars for grinding. Carnivores, you have a little bit more going on, right? As you'd have pointed incisors, you'd have big canines, you'd be able to shear off big pieces of meat and swallow those. And in omnivores, like humans, we've got a variety of specializations and we can accommodate both meat and vegetables. So you can see here we've got some incisors, we've got some flat molars. So we've got kind of a little bit of everything within our mouth, and we've got, I think, about 32 teeth. Okay, and then going into the human digestive tract, again, it is complete. We do have an alimentary canal. It's part of a tube within a tube body plan. And as you know, it begins with your mouth and ends with your anus. And it's entirely extracellular. Okay, so this is important because it is different than other animals, but we'll keep it confined here to humans. And we have a lot going on in digestion. So we have things that are being mechanically digested that we'll talk about here in a minute, as well as chemically digested. And we have the chemical digestion happening through digestive enzymes, and those digestive enzymes are coming from the wall of the digestive tract or by nearby glands. So just kind of a quick overview of the digestive tract, and then we'll get into it a little bit further as we move on. But again, we're starting with the mouth, going into the mouth, and we're doing some chemical and mechanical digesting here in the mouth and forming what's known as a bolus of food that is then going down. This isn't the bolus, sorry, I don't know why I'm circling it like that. But after you swallow it, which is one of the steps of digestion, Then it will continue to go down through the pharynx into the esophagus. So I guess kind of backing up, we've got 6 basic steps. So we have ingestion, which is here, right? We're taking in the food. And then once we swallow it and we go down into the esophagus, which is basically this big tube going down to the stomach, that's in our second step, which is known as propulsion. So we'll talk about all this in a second here, but just to give you an overview, ingestion, propulsion, and then we have mechanical breakdown that's happening, and then we have chemical digestion that's happening here in the large intestine, and then we have absorption also happening here, and then defecation happening out the anus. Okay, so starting with the very first part, the ingestion with the mouth, we do have 3 major pairs of salivary glands, and I just heard actually that we produce about 4 soda cans of spit every day, or I think it's about 1.5 liters. So that's a lot. That's a lot of saliva. And in that saliva, we have something called salivary amylase, and that's what initiates starch digestion. So these 3 glands here, those are all secreting enzymes that are used for chemical digestion of the food that is entering the mouth. And then the tongue here is basically helping mix that chewed food with the saliva to give it both a little bit of mechanical and chemical digestion. And then it's going to form a mixture or form that mixture of all the broken down food that you have in your mouth into a bolus. And then that bolus is going to be swallowed, where it will enter the pharynx. And this is where digestive and respiratory passages kind of come together. So if you've ever heard someone start coughing a lot because they just swallowed food or drank something and they said, oh, it went down the wrong hole, probably didn't. But the reason why you say that, right, is because of the pharynx, because you have digestive and respiratory passages coming together, and you have this thing called the epiglottis, and that's what covers the opening into the trachea, which is where air is going through, right? That's our getting into the respiratory system. So the epiglottis basically closes off and forces that big bolus of food through the pharynx down into the esophagus. So again, swallowing, you have the lips, you have the jaw, tongue, and then what's going to happen is that tongue is going to move that bolus of food down into your pharynx down here. Okay, once it goes through the pharynx and the epiglottis is stopped, it's going to then get into the esophagus, and that's going to take the food to the stomach by something called peristalsis. So this is the second part of digestion where we're into the propulsion phase. So this is where we're getting rhythmic contractions that move that bolus down from the top of your esophagus, or kind of near like the top of your body essentially, into your stomach. So this is happening rhythmically, and it's something that's really important. It's something that actually has a decent amount of power. Like if you were to, be upside down, this would still contract and make its way into your stomach, which is pretty impressive, really, when you think about the gravity of that. Okay, now once we're in the stomach, then we can get on to the third step, which is mechanical breakdown. And essentially what's happening in a mechanical breakdown is we're wanting to increase the surface area of our food, right? We're wanting to increase the surface area of our food so that we can get more enzymes to it to help break it down as well. And in your stomach, you've got these really deep folds, and they kind of disappear as the stomach fills to an approximate volume of 1 liter. And the reason why our stomach doesn't just like eat itself basically is because it's got this epithelial lining, and it's got a big mucus layer covering it. So that's why all that gastric acid that's within your stomach and has a really low pH isn't essentially dissolving the stomach itself. But within that epithelial lining, there's millions of these things called gastric pits that drain gastric glands. So you get different enzymes coming in, like pepsin is one of the most common. It's a hydrolytic enzyme that acts on protein to produce peptides. Okay. and lots of other enzymes in the stomach too. And again, just a generally very low pH to help break down the food even further and increase that surface area of the food. So when that food is mixing with all those gastric juices in the stomach, it becomes something called chyme. Okay, so chyme is then going to be passed from the stomach down into the small intestine. The junction between your stomach and small intestine is controlled by a sphincter. So you actually have a sphincter on top of the, say this is your, draw really quick. Say this is your stomach here. We actually have a sphincter up here coming from the esophagus. And then we have a sphincter down here that allows for that food or that chyme, right, to go into the small intestine. And it essentially stops backflow, right? So we need these two sphincters here to stop backflow of food going back into the esophagus or chyme coming, instead of going to the small intestine, maybe coming back into the stomach. So when that sphincter relaxes, that's when you get a small quantity of chyme that'll pass into the small intestine. And the first segment of the small intestine is called the duodenum. So chyme is going to enter the duodenum and then mix with secretions from the liver and the pancreas. So the liver, pancreas, and small intestine are all producing these enzymes that are helping absorb or chemically break down the food as well. In addition, we have a liver, right? Liver is actually like the largest organ in our body, and it produces something called bile, which is stored in our gallbladder. And within that bile, we've got these things called bile salts that's help breaking up fat into these little fat droplets via emulsification. So this is something that helps maintain the glucose concentration in your blood by converting any extra glucose that you have into something called glycogen. Here's just kind of a schematic of liver, gallbladder, and pancreas working together to make these enzymes and bile and different essentially juices, right? Like pancreatic juice that's full of enzyme that's going to then work together with the small intestine to help break down more of this food as well. Okay, so in addition to the liver, we have the pancreas. This is also known as the exocrine gland. It produces the pancreatic juice and digestive enzymes into the duodenum, which is the first part of that small intestine. And then we have different enzymes that are being released here. Pancreatic amylase, which is digesting starch to maltose. Trypsin is digesting protein to peptides, and lipase is digesting fat droplets to glycerol and fatty acids. So I guess backing up a step here, remember from when we talked about metabolism is that we have these macronutrients. There's 4 macronutrients. There's proteins, carbohydrates, lipids or fats, and nucleic acids. So of these, we're taking in all of these through our diet essentially, but we're breaking down our starches or carbohydrates here with pancreatic amylase, trypsin digesting protein, and then lipase is digesting those fats or those lipids, right? Lipids are basically the same thing as fats, so that we can make fatty acids, which go into making things like your phospholipid membranes or different sterols within your body as well. Epithelial cells in the intestine are also producing enzymes, and then all of that together is completing digestion of peptides and different sugars. Okay, so we went through the steps here. We have ingestion. Again, you can see the swallowing, and then I usually consider the propulsion to be the second step after we swallow, and we go through peristalsis to get it into the stomach. And then we're going through mechanical breakdown into chemical digestion as well. You can kind of see here what we're considering mechanical is chewing, churning within the stomach is mechanical as well, and segmentation within the small intestine as you're dividing it in between the duodenum, the ileum, the jejunum. Those are helping in that mechanical digestion as well. I won't be super concerned. The duodenum is one that you're going to hear a lot, but I'm not super concerned about you necessarily knowing the other parts of the small intestine for our purposes here in this lecture. And then we have absorption that's happening. So chemical digestion is happening really throughout, right? It starts in your mouth and it's going down, but a large chunk of it's happening in the large intestine. And then once that's all, once the food is essentially as digested as it's going to get, then we have absorption. So nutrients and water are going to enter the blood vessels and lymph vessels in the small intestine, and then water to blood vessels in the large intestine. So lots of water being absorbed, and then from this food that's broken down, the water is going to be absorbed back into the bloodstream essentially, and then the drier waste is what's actually going to become feces here and will be exited out of the rectum. So just another like image for you or diagram essentially to kind of help you with what is mechanical and what is chemical in different parts of the digestive tract. Okay, so absorption. So this is occurring in the small and large intestines. And again, within the small intestine, we still have this mucous membrane, and it's got lots of ridges and furrows that are giving it a corrugated surface. Villi are ridges on the surface, and they contain even smaller ridges called microvilli. And what this does is it increases our absorptive area. So we're increasing surface area here as well, and so that we can absorb more of the nutrients from this food. So each villus, these little, they're almost like hair-like things too, kind of like cilia, really. And those have blood capillaries on them as well as a lymphatic capillary called lacteal. And that is just helping absorb more of the nutrients that are going through the small intestine. Okay, so that's generally how digestion is happening within our bodies. Now we're going to get into talking about some of those macronutrients and how they're actually digested. So again, we have carbohydrates, proteins, fats, and nucleic acids. So starting off first with carbohydrate digestion, and essentially in all these macronutrients, we start off as a polymer, right? That means that they have lots of different monomers linked together. In this case, we have our sugars, right? Polysaccharides means that we've got something like glycogen and a starch. So we've got lots of sugars involved here, and we're going to use amylase that's further up in the digestive tract, like in our mouth, our saliva, in our stomach, to convert it to a disaccharide, maltose, to eventually get it down into a glucose. So remember, the whole point of eating food is so that we get energy, right? And in order to get energy, we've got to break it down into a currency that makes sense for our body, which ultimately our currency is what? Our energy currency for humans and other animals is ATP, other eukaryotes, I should say. So in order to get to ATP, in order to go through the whole process that we can get to, we need to have glucose. And so we need to go from a starch like glycogen or a polysaccharide into a monosaccharide. We're basically working from a polymer to a monomer. That's the whole point of digestion, is to break it down so that it's essentially just one thing that can then be used to convert into an energy currency that makes sense for our body. So you'll see that with other sugars as well. These are just disaccharides, not a polysaccharide, but you can see that we use sucrase or lactase to break down sucrose or lactose, and that will then divide down into monomers or monosaccharides that are glucose and fructose or glucose and galactose. Okay, so for these carbohydrates, they're being digested by lots of different enzymes. Starch and glycogen, again, broken down into glucose by amylase and maltase. Sucrose, which is table sugar, lactose, which is milk sugar, are both broken down by sucrose and lactase, or sucrase and lactase, respectively. Whenever you see something ending in ACE, that essentially gives you a good indication that it is some sort of enzyme. So just keep that in mind. Okay, for protein digestion. So again, we're going from a polymer down into a monomer. We're trying to make things smaller through digestion. So a large part of your protein digestion is actually taking place in the stomach. And you think about what are proteins, like if you are a meat eater and you're eating beef or something, that's something pretty substantial, right? And it does still start breaking down in your mouth through that mechanical and chemical digestion, but that's going to take a bigger toll in the stomach. And pepsin is really playing a very important role in digestion here, because it's breaking down all of those intact proteins into peptides, which are shorter chains of 4 to 9 amino acids. So now we're getting to the heart of what a protein is. A protein is just a bunch of amino acids linked together, right? So we're breaking it down into smaller chunks of amino acid. And once we get into the small intestine, and specifically into the duodenum, then we have other enzymes that are coming from our pancreas, like trypsin or elastase, chymotrypsin. Those are acting on these peptides that we just broke down, and they're reducing them to even smaller peptides. Okay. Specifically, carboxypeptidase, dipeptidase, aminopeptidase, those are all playing important roles in reducing peptides into what are known as free amino acids. So again, going from a polymer up here into a monomer down here where we just have free amino acids. I think of just singular amino acids kind of floating around. And then those are getting absorbed into the bloodstream through the small intestines. Okay, lipid digestion. This is our fats, right? This begins in the stomach as well with the aid of lingual lipase and gastric lipase, but the bulk of it's actually happening in the small intestine. So fats aren't being digested as much in the stomach like the proteins are. They're actually working their way into the small intestine and being broken down further by our pancreatic lipase, right? So when that chyme, that digested ball of food essentially, enters the duodenum or the small intestine, the hormonal responses trigger the release of bile that's coming from the liver, and it was stored originally in the gallbladder. And then that bile is going to aid in digesting those lipids, primarily triglycerides, by emulsification. Okay. Okay. Sorry, this is in here twice. Notice. Okay, now getting into the large intestine, because we didn't talk as much about that before, but the large intestine, again, is where we've got even more chemical digestion happening, and importantly, a lot of absorption as well. So the large intestine includes the cecum, the colon, the rectum, and the anal canal. Very large in diameter, but shorter in length than the small intestine, which can be kind of confusing. So remember, you've got more small intestines kind of to go around, but you have a larger diameter in the large intestine. And what's mostly happening down here is we're absorbing water, salts, and some other vitamins as well. Excuse me. Your cecum here has a small production called an appendix. And then the colon is divided into ascending, transverse, descending, and sigmoid colon. Not too important for you to know right now. And then we have the opening to the anal canal, the anus, and that's to eliminate the other drier waste that we then have turned into feces. So obviously different things can happen here. You can have either constipation or diarrhea. Constipation is when your feces is so hard because you have excess water removal happening in the colon. And then, you basically can't excrete out that waste. Diarrhea is the opposite problem, where we don't have enough water being removed from the feces within the large intestine and the colon area, and that's when we get diarrhea. And you can see here about a third of the fecal matter is bacteria, whether it's live or dead. So that's why we're always telling people to be really careful and to really avoid handling any waste as much as possible. Okay, so that's how digestion works. And I do want to get into nutrition a little bit as well. We've talked about it some in metabolisms closer to the beginning of the semester, but we'll talk about it here as well as provide you with some instructions for completing your assignment. And I'm sure you've all seen the food pyramid, right? We want to use these sparingly that are up at the top, like fats, oils, and sweets. And then we want to eat more of these things that are at the bottom in general. But do we really want a lot of bread, cereal, rice, and pasta? Maybe not, right? Maybe we don't want a ton of carbs necessarily. It really depends on you. And I think that that's something to keep in mind when we talk about some of these. Some people, I think, are genetically predisposed to handling different things better, right? We know that's true in a lot of different cases, and I think nutrition is no exception. Some people can handle carbs really well. They could eat plates of pasta and, they're not going to gain weight. They're going to be able to digest it really well. Some people can't do that. Some people have digestive issues, right? Like whether you have celiac disease and you can't process gluten molecules, or, there's different things. So just keep that in mind as we're going through nutrition as well. Okay, so again, our macronutrients that we have carbohydrates, proteins, fats, and then nucleic acids is our fourth one. And the reason why this is important is because these are the things that we're breaking down from, again, some sort of polymer or like a polysaccharide here. These are all of our amino acids chained together here and all of our lipids here. We're breaking them down from more complex to less complex. And the reason we're doing that is to get energy. So you've heard of calories, right? 1 calorie, lowercase c, is the energy that you need to raise 1 gram of water 1 degree Celsius. Whereas 1 calorie with a capital C is actually 1,000 calories and equal to 1 kilocalorie. So this is actually what we see on food labels here. It's not as common anymore, but it used to be that calories was always capitalized when we were talking about kilocalories. It's not as common anymore, so you might not necessarily see that, but that's something to keep in mind when you're reading food labels. And something that we're going to be using for today, when you're looking at food nutritional labels, or even drink nutritional labels, either one, we're going to be compartmentalizing them. So carbohydrates actually have 4 calories per gram. Proteins also have 4 calories per gram, and fats actually have 9 calories per gram. Makes sense, right? When we're eating fats, we're consuming more calories, and that's going to technically give us more energy store as well. Fats are a little bit harder to digest, and we end up storing a lot of those lipids in different sorts of ways. Okay, so carbohydrates we get in the form of sugar, starch, and fiber as well. Fruits, vegetables, milk, honey, those are all natural sources of sugar. We do have monosaccharides within that, like glucose and fructose. This is ultimately what we want to break everything down into anyways, is usually glucose. There are disaccharides as well, like milk sugar, table sugar, lactose, and sucrose. And after being absorbed from the digestive tract, all sugars are converted again to glucose, right? That's our preferred direct energy source in cells, so that we can take glucose and oxygen and go through our respiration cycle in order to make something called ATP, which again is giving our body the energy currency that it needs. Plants store glucose as starch. Animals store it as glycogen. So that's how it's stored within your body if it is being essentially saved for any day. Talking about fiber as well, these are undigestible carbohydrates derived from plants. And we want a good amount of fiber in our diet, right? So we want to eat things like beans, peas, nuts, fruits, vegetables. It's not really a nutrient for us. It can't be digested, but it does still help keep our digestive tract regular, right? It combines with different bile acids and cholesterol within the small intestine, and it prevents them from being absorbed, which is something that we want to some extent, but you don't want too much fiber or too little fiber, so it is something that you have to kind of play with in your diet to make sure you're getting an appropriate amount. Proteins. Okay, so adequate protein formation requires 20 different types of amino acids. We, as human adults, we require 8 from our diet. Children actually require 9, and those are what are referred to as essential amino acids. Essential amino acids means that our body cannot make these amino acids on its own. It has to get them from the diet. So we have to intake these into the body. Otherwise, we will not have them. And we have to have these 8. Children have to have 9. Okay, so some foods like meat, milk, eggs, those provide all 20. Those are considered complete foods. Vegetables usually supply 1 or more essential amino acids, but they're always deficient in at least 1. So for vegetarians and vegans, you've got to kind of think about this to make sure that you're getting the right essential amino acids in your body and making sure that your diet is staying on track. It is a little bit harder as a vegetarian or vegan just to keep track of these things. And it's not really hard or impossible, but if you're coming from an omnivore lifestyle, going into being a vegan or vegetarian is something to kind of keep in mind. You've got to be able to combine these plant products to provide all the essential amino acids. So you have to know which ones have which amino acids to make sure that you're getting the whole gamut. Okay, so kids need arginine, which is the one that's not listed in these 8 essential amino acids. And again, you can get them from vegetables. You just got to make sure, or like beans, you just got to make sure that you're kind of overlapping your diet so that you're not just eating, let's say you just live off corn. You want to be that corn kid. You can't do that, right? We've only got 6 out of the 8 versus if we add corn and beans, now we've got all 8 covered. Okay, last for our macronutrients, we have our fats, which is our lipids. This is fats, oils, cholesterol. This is essential for storage and activity of fat-soluble vitamins like A, D, E. And again, it's providing energy at 9 calories per gram. It's essential to protect all of our internal organs. It helps us insulate against cold temperatures as well. And we have saturated and unsaturated fats. We've gone over this a little bit within the metabolism lecture, but saturated fats, these are the ones that are solid at room temperature, usually coming from animals, so like butter, meats, the marbled red meats, bacon, those have saturated fats. Palm oil and coconut oil are also high in saturated fats. And again, those will turn solid, not necessarily at room temperature all the time, but maybe a little bit colder. And I didn't talk about the unsaturated fats, but don't worry too much about that. And as far as diet and obesity, is something we hear talked about quite a bit, right? And this is when you have too many calories from any source that's contributing to your body fat, and then you get increased risk of obesity and associated illnesses like type 2 diabetes or heart disease. Different cardiovascular diseases are often seen in people who are obese, or like this cat, or big cat, I should say. So we talked about the macronutrients, macro meaning big. Now we have something called micronutrients, like our vitamins, which are something that we also need to intake through our diet that our body needs, but we need it in micro doses, meaning we need it in smaller doses. So again, these are organic compounds that we're usually unable to produce, but we do need them for metabolic purposes. So we're going to obtain them externally. Most of the time they're water or fat soluble. And if we do have a vitamin deficiency, like say we have an iron deficiency, that can have a really dramatic effect on your health, right? So you want to make sure that you're getting the appropriate level of these micronutrients so that your body can function at its optimum. Antioxidants like vitamin C, right? Vitamin E and A, those are also believed to defend the body against what are called free radicals. Vitamin A, D, E, and K, those are all fat soluble, whereas water soluble vitamins include vitamin B and vitamin C. So essentially what that kind of means is that water soluble means it's going to release into the water, right? So if you take in too much vitamin B or vitamin C, really there's not much of an issue with it. You're just going to pee it out. right? Fat soluble, you could have too much of these vitamins, but usually the concern is a deficiency in any of these. So you can read through them and understand what the different vitamins do, like promoting eye health, healthy skin, helps your body absorb calcium. You guys probably know that one. Vitamin E, antioxidant, vitamin K, blood clotting. B is our energy, growth, development. C, immune system, fight skin aging. It's an antioxidant. These are all important vitamins that we do need within our diet. We also need within our diet micronutrients, include both vitamins and minerals. And these are inorganic essential nutrients that, again, have to be obtained from food. Okay, so they help in structure and regulation and are considered something called cofactors. We won't go into that too much, but just have a look at this table and understand what minerals our body needs, what they do for us, and where we can get them from. Okay, so we're going to talk about our assignment for this week is reading food labels. You are going to get 2 foods of your choosing, or drinks if you would like. I would kind of prefer it be a food, but either way, just please make sure it is not a 0-calorie food. I do want to make sure that you're actually going through and understanding some of this. But just know that all of your nutritional values are calculated for 1 serving. So if you're using more than 1 serving, like our example today is going to be this half of a pizza. If you eat the whole pizza, consider that when you're talking about this. For the assignment, you can just use the serving size. That's fine, because you're going to be doing calculations based off of that. If you want to use what your actual serving is versus what the serving size is, you can do that. Just, maybe make a note of it. Say the serving size is 1/2 of pizza. I ate the whole thing, so I'm going to multiply these things by 2. Okay. So if we eat this entire pizza, how many total calories would we consume? So we're just multiplying 390, which is our total calories here, by 2, since we're eating a whole pizza. So we'd have 780 calories. So the USDA, sorry, this is cut off a little bit, has determined a daily value for each nutrient, meaning that's how much of that nutrient you need in your diet. Again, keep in mind, not everyone needs 2,000 calories a day, right? You figure that out when you figured out your basal metabolic rate, your BMR, what your calorie intake should really be per day, and that depends on whether you're trying to maintain your weight, lose, or gain. But most percent daily values are based on a 2,000 calorie diet. So we see here total fat less than 65 grams, saturated fat, cholesterol, sodium, total carbohydrates, dietary fiber, all of that, right, is based on quote unquote an average person. So this doesn't actually apply to many, many people. So how do you actually know if you're getting enough or too much of a nutrient? Percent daily value is going to measure how much of your required daily value of a nutrient is provided by that food. So as a good rule of thumb, if it's less than 5%, it's a pretty poor source of that daily value, right? So for this pizza, let's say, like vitamin C, 0%. This is a poor source of vitamin C. We're not getting roughly any vitamin C from this pizza. 5 to 20%, good source. Cholesterol. Do we want a good level of cholesterol? Ideally, cholesterol is one of those that we don't really want like a ton of, but it's an acceptable amount, right? If it's over 20%, it is an excellent source. Again, do we want 20% of something? Really depends. Do we want that of like a vitamin? Maybe. Do we want that of a fat? Maybe. But if we're taking in 28% of our daily value with each serving size, that can add up really quickly, right? So it just depends on what else is in your diet for your daily intake and whether you consider that to be actually healthy or unhealthy, quote unquote. But as a rule of thumb, less than 5% poor, 5 to 20 good, and over 20 is an excellent source. Okay. So this would be an excellent source of fat, saturated fats, a whole gamut of different things. Okay, so what is the percent daily value of sodium provided by 1 serving of this pizza, assuming a 2,000 calorie diet? So you can see here, sodium, 830 milligrams. What is the percent daily value? We don't know it, right? So this is what you're actually going to be doing in your assignment, is you're going to be calculating out how much your percent calories are from each one of these. So this tells you a percent of your daily value. It doesn't tell you how much of these calories are actually from fat, right? So we know we have 18 grams of fat, but we don't know how many calories that is or what percentage of calories of the thing that is. Keep in mind too, for saturated fats, trans fats, unsaturated cholesterol, when we're looking at this, saturated fats are 10% of your total calories, which means it's a third of your total fat intake. That's quite a bit for the whole day. Trans fats we want as little as possible. Unsaturated fats, about 20% of total calories, which is 2/3 of your total fat intake. That's the rest from your saturated fats. And then cholesterol, we want ideally less than 300 milligrams a day. Okay. So under total carbohydrates, you'll see different things. So you'll see the total carbohydrates, dietary fiber, sugar, sugar alcohol. Sugars just means simple sugars. Sometimes you'll see other carbohydrates, which might mean complex carbohydrates. If you do keto, or if you've ever been curious about that, you'll hear people talking about net carbohydrates, which is usually your total carbohydrates minus your dietary fiber. Usually, I think people do it a different way sometimes, but so like in this case, we'd have 44 grams minus 3, so our net carbohydrates would be 41. Not very good if you're trying to eat keto, which means that you're eating really low carb. Just one example of a very popular diet right now. Okay, so again, sorry, this is probably the wrong page number for you guys, so ignore that, but again, we need these things in really small amounts to maintain enzyme function in human health when we're looking at our minerals and nutrients. So you can see here our sodium is actually 35% of our daily intake. So it is actually quite a bit of sodium in this, which means usually like very salty food. So we want to stay away from that ideally. Keep in mind too, ingredients when they're listed are starting with the highest. So when we're looking at this pizza, for instance, the biggest ingredient in it is wheat flour, followed by water. And then we have mozzarella cheese, and then we have tomato paste, spinach, mushrooms, so on and so forth. So usually if it's in the first 3 or 4 ingredients, that's a pretty major ingredient. Keep in mind if you're like looking out for sugars and you're like, oh great, this doesn't have sugar in it. It doesn't always just say sugar, right? Sometimes it says brown sugar, high fructose corn syrup, molasses, honey. There's lots of different things that it can say. Also, for trans fats, we saw that this had a very small amount of trans fat. I think it was 1.5 grams. Keep in mind, if it's less than 0.5 grams, the USDA will allow you to report that as 0 grams. I know it seems small, but let's say that we're eating something and it's like a serving size is 1/6 of the box or something like that. Well, if it's 0.5 grams and you're eating all 6 servings, not that maybe you should be doing that, but we all know we do that kind of thing sometimes. Sometimes serving sizes seem really small to us. So let's say you do that. You've actually taken in 3 grams of trans fat while believing that you've had 0. Okay. So it does add up. Keep that in mind. It's not just trans fats that nutritional labels will do this for sometimes. Sometimes they round down on a lot of other things as well. So something to keep in mind. Okay, so like I said, we know, I forget already, but I know that I have 390 total calories, right? And let's just say I have 18 grams of fat. I don't know if that was really what it was, but bear with me. How do I know how much of that fat or how many calories are in that fat? Okay. So this is grams of fat. I know I have 18 grams of it. And I know that for fats, every fat has 9 calories per gram. So I'm going to multiply this together. Okay, so I'm going to do 18 times, which is 162. Okay, and my grams are going to cancel out here, so I'm going to have 162 calories. So from my fats, sorry, let me just write fats here, and excuse my poor penmanship, but from my fats, if I have 18 grams, now I know, okay, my fats is actually 162 calories. So that's a lot of calories just from fats. What percentage is that? That's what you guys are going to be calculating on your nutritional label. So you're going to take that number, 162 calories, and you're going to divide that by the total calories, which is up here, 390 calories, and you're going to multiply that by 100 to get your percentage. So in this case, we have 162 divided by 390 is 0.4, let's just say 0.42. Going to multiply that by 100, so I have 42%. Okay. So I know nutritional labels tell you the percent of your daily value, how much fat you should be taking in, right? Which wasn't this number. But when you actually eat that half a pizza, just know that almost, well, 42% of the calories from that pizza are coming from fats. Okay. So you're going to do the exact same thing. Let's pretend like we had still our 390 half pizza, 390 calorie half pizza. Let's say we have 6 grams of protein. Okay. So how do I do this one? What do I multiply my grams of protein by? Well, if you'll remember, fats are 9 calories per gram, and carbs and proteins are 4 calories per gram. Okay. So I'm going to multiply 6 grams by 4 calories per gram, and I'm going to divide that whole thing by 390 and multiply it by 100 to get 24 over 390. Okay, what is that? That is 0.06 times 100, which would equal roughly 6%. Okay, so 6% of the calories in this case, again, this isn't what it really said. I forget what the actual numbers were. Just as an example, 6% of the calories are coming from our protein here. Okay. So when you do your food analysis, this is what you're going to be doing, is you're going to be answering all the questions there. There are some questions talking about some different things at the end, but the first couple tables that are spread out upon the pages are for you to analyze food labels. So you're going to analyze 2 food labels, and some of the answers will already be written on the label, but some of them, like calculating out the percentage of fat, percentage of protein, blah, 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 all of that is things you will need to calculate. Again, we're going to do for fats, 9 calories per gram, and carbs and proteins, 4 calories per gram. So you'll be calculating out percent calories from each of those macronutrient categories. If you have any questions, please let me know, but I hope you enjoy kind of analyzing your nutrition. If you would like to track it over a few days, you could definitely do that. I have some things to guide you in that as well if you're interested, but hopefully this is something that was interesting and can apply to your nutrition now as well.